Hello and welcome to this presentation for ICSE 2020. The work is on establishing multi-level tester code traceability links, and it was carried out by myself, Robert White, Jens Kronke, Raymond Tan from the University College London Crest Centre. So this work is concerned with establishing tester code traceability links, which essentially map tested artifacts to their test artifacts. So at the class level, we're mapping test classes to their tested classes, and then at the method level, we're mapping test methods to their tested methods. The reason why we want to establish these types of links is for several reasons. Firstly, we want to keep tests in sync with code. So when code is updated, we want to make sure that the relevant test artifacts are also updated. And in doing so, we try to reduce test failures and missed faults. These links also help to maintain our architectural consistency. For example, if the architecture demands that we have a single test class for each implementation class, looking at these links can help to determine if that architecture is being maintained. They're also helpful for getting tests for recommender systems and also for building corpuses of training data for machine learning systems that can be applied in a whole range of contexts. So therefore, maintaining these types of links can be very beneficial for the software engineering process and the resulting software. However, maintaining these types of links manually can be time-consuming and error-prone, as we have to ensure that developers create the links and then update the links when the system changes. Due to this, where links are maintained manually, it's usually only at the class level. So therefore, it would be very useful for us to have reliable techniques for automatically establishing and maintaining these links. And in previous work, some techniques have been attempted, and these four are four of the main ones. All of them have their own individual benefits, however, they all have quite severe weaknesses. For the call-based techniques, we see that over-approximation is a problem, wherein getters and setters are incorrectly linked, as well as utility functions. For naming conventions, in projects that do follow the naming conventions, we can see high precision, however, we can get low recall, where in instances where the naming conventions aren't followed, and if a test tests multiple functions. For last call before assert, we see the assumption does not always hold, in that the last call function is not always the tested function, for example, if it's a getter or a function for establishing an oracle. And for information retrieval, there's a weakness in that it treats code like natural language. It ignores the bimodality of code, which is that code is also specifying an execution. It isn't just a language. So, in order to overcome the weaknesses of the existing techniques, we have formulated an implemented approach called TCTRACER, and it improves on the existing techniques in three main ways. First of all, it utilizes an ensemble of existing and new techniques, with the idea being that the strengths of the individual techniques will be combined. We also operate at both the method and the class levels, which previous systems haven't, and we use this fact to utilize multi-level information to improve effectiveness at both levels. So for our technique ensemble, we break them out into naming-based and call-based techniques. For the naming-based, we've selected the traditional naming conventions, as discussed previously. However, due to the weaknesses of this technique, we also propose a new technique, which is naming conventions contains, which is the same principle. However, instead of the names having to match exactly, the test name only needs to contain the name of the function, so we can map multiple functions to a single test. We then have two variants that utilize longest common subsequence. The first variant essentially is an extension of the traditional naming conventions NC, because the score is maximized when the test and function name match exactly. The second variation is an extension of NCC, because the score is maximized when the test name contains the function name. So effectively, these LCS variants are real valued scores that are an extension of the binary scores for NC and NCC. And then we have a Levenshtein score, which is also a real valued score, which takes the Levenshtein distance between the names and scales it by the length of the longest string. For the call-based techniques, we have LCBA, which was discussed previously, and we also have one based on term frequency, inverse document frequency from information retrieval, in which we take the same technique, but we recast the roles of the terms with functions and the roles of the documents with tests. We also have a technique based on tarantula statistical fault localization, in that we assume that the test that we're trying to generate links for is the failing test, and all other tests pass, and then we utilize that technique to find the functions. So, the TCTRACER approach overall is split into the method level and the class level. And starting at the method level, we take the tests and the functions and we apply the techniques. We then create a combined score, which is an average of all of the other scores. And these make up our method level scores. We then use those scores to make link predictions, which are the predictions with just that level of information. We then do the same thing on the class level to get those predicted links. We then move on to the multi-level augmentation. And here first we take the method level scores and try to use them to predict class level links using these elevated method level scores. Then on the other side, we take the class level scores and use them to augment the method level scores, and then use those scores to produce more predictions. So we end up with predictions for each level using just that level information, and each level using information from the other level. And we can then compare and see which is the best performing technique. And we do that in our evaluation, which includes 3 projects at the method level and 4 projects at the class level. For the method level, we use a manually generated set of Oracle links. And for the class level, we use predominantly developer-provided links that were in the code. And if anybody would like to use this ground truth in their work, it's available at that link there. And we have the artifact available in reusable evaluation badges. For the evaluation measures, we use precision recall and mean average precision to look at ranking performance, and we look at the area under the curve because it's threshold independent. So for the results, we see that for RQ1, this is looking at how effective are the techniques at the method level using just method level information. And here we see that the combined technique is the most desirable because it performs best for MAP and AUC. That shows that it's good at ranking predictions and that it's consistent when changing thresholds, and that it could in fact perform even better with a more optimized threshold. For RQ2, we look at the class level links with just the class level information. And again, the combined technique is the most desirable. And we see that the techniques compare similarly to each other, except that the scores in general are higher because it's an easier task. For RQ3, we look at establishing class level links using method level information. And here the results are not as good as RQ2. So that shows us that it's better to use just class level information in this instance. However, in RQ4, where we look at making method level predictions using class level information and method level information, we see that the augmentation does improve overall results. So here the multi-level information is adding benefit. So that was TCTRACER. It's an approach and an implementation for establishing tested code traceability links. We're the first system to establish links at both method and class level. And also we utilize a combination of new and existing techniques, leveraging the multi-level information to improve performance. And if anybody would like to use the code or the artifacts in their own research, it's available at those links. Thank you very much.